Hi everyone. In the last video, we were discussing about the different loading schemes. In that, compile and loader scheme has already taught in the last video. In today's video, we are going to study about the second loading scheme, that is general loading scheme. Before moving on to general loading scheme, let me give an overview of the compile and go loader. In the compile and go loader, we stored both the assembler and the output of the assembler, that is the assembled instructions or the machine language instructions, and data for the execution has been stored into the memory. Okay, so that was the structure of compile and go loader. Now we are moving on to general loader scheme. In the general loader scheme, first you can start with the diagram. You can see here, this is the representation of your general loading scheme. Here you can see this is the memory representation. In this memory, we are not storing our assembler program. Instead of that, we are keeping our assembler program outside, and we will give the source program as the input to the assembler. Assembler will generate the output, that is the machine language instructions, and it will be punched on a card. Card is nothing but it is a storage device. It has some storage area, and this coded instruction is called object program or object deck. Whenever we want to execute this program, only that time we will load the corresponding object program into the memory. Immediately after the output of assembler, we are not directly storing into the memory. Whenever we want to execute this particular program, only that time we will load our object program or the output of the assembler in the object deck form into the memory, and that will be performing by the loader. Here the loader will be accepting the output of the assembler in the object program form or object deck form, and it will be loaded into the memory. And also the memory will be consisting of the loader program. So whenever we compare the size of loader program and the assembler program, the size of the loader is very small. So more memory will be available to the object program. Now let's see the points of this general loader scheme. As I told you, the output of the assembler is saved and loaded whenever the code is to be executed. That means if we have a source program to execute, only whenever we require to execute that program, only that time we will load the output of the assembler and the data or the into the memory. Okay, until that time the output form or the output of the assembler, that is the machine language instructions or the assembled instructions, will be punched on the card. And this card is a secondary or just a storage device. It has some storage area, and this coded instructions is called object deck or object program. And whenever we want to execute this program, that time only the corresponding object deck or the object program will be loaded into the memory. Since here we have an intermediate form, that is the object deck or object program, we require an additional program to load this object deck into the memory. So that's why here we require the program for loader. Use of object deck requires the addition of new program, that is loader. And loader is smaller than assembler, so more memory is available to the object program. And we'll see what is the function of loader in the general loader scheme. In the general loader scheme, loader accepts the assembled machine instructions, that is the output of the assembler, which is punched on the card, that is the object deck or object program, and the data for the execution into the memory in an executable form. Let's see what are the advantages. In the compile and go loader scheme, the disadvantage was, since the assembler is occupying in the memory and it is a big program, more memory will not be available to the object program. There is a wastage of memory. But here we are storing loader and the output of the assembled output of the assembler into the memory. Here loader is a small program, so it won't take more memory. So more memory will be available to the object program. And another one is here, how many number of programs we have, all the programs will be given to the assembler, and the output of the assembler will be stored in the form of object deck or object program. So the general loading scheme will be supporting multiple segments. Multiple segments means multiple programs written in multiple languages, which is not supported by the compile and go loader scheme. And another one is, suppose how many times we are editing the source program, no need to again load and again and again loading into the memory. In the compile and loader scheme, since the assembler was in the memory, whenever we are changing the source program, each time we need to retranslate. But here we have no need of retranslation, because assembler is keeping outside the memory, not in the inside the memory. That's all about the general loading scheme. In the next video, we will be explaining about the third loading scheme, that is absolute loader. Thank you. Thank you for watching.